All right, so here I have your solving inequalities notes here. So this is the first 2 pages. So I have been calling this 1.5-1 and -2, I believe. These are just regular inequalities, graphing inequalities, multi-step inequalities, okay? So let's scroll down. So this is what I have put videos out on before. Let's scroll down to the compound inequality. So this one is the OR type, which I've been calling 1.5-3, and then we have the AND. So I'll do some notes on this one here. I've already written in the definition for compound inequalities. So when we talk about compound inequalities, we're just talking about 2 or more inequalities graphed together in the same number line. So your solution set is usually dictated by 2 different conditions, okay? So if we take a look at this graph right here, a couple things. We have 2 circles here. One's open, one's closed, and then arrows pointing in either direction, okay? So we know that this is going to be an OR compound, right? Because there's some parts of the graph that are missing here. So it can either be over here, or it can be over here, right? But not including the 1, it looks like. So the way that we are going to write this is that x is, so we'll look at the left side here, x looks like less than or equal to -4. And we know that because the circle is at -4, and it's going to the left, so we know it's less than, and it's a closed circle, so we know it's less than or equal to. And then we write or, x is, so here is 1, so this is going to be our marker here. We're going to the right, so x is going to be greater than 1, and it's not going to be equal to because the circle is closed there. I'm sorry, the circle is open. Okay, so we write it as x is less than or equal to -4, or x is greater than 1. Okay, and hopefully you've already watched my video on notation, so you'll kind of have an idea of where this is going. But the interval notation, since there are two different places on the graph where the value of x can be, we write this in 2 different intervals. Okay, so it's going to be just like the other kind. We're just going to connect 2 different intervals. So let's look at the first one where x is less than or equal to -4. Okay, so the lower bound here we're going to write as -infinity, right? It's going in the left direction forever. That always gets a parentheses, okay? And the upper bound is going to be -4. It's going to get a bracket because it includes -4. And we know that because of the closed circle and because there's the equal to underneath. The second interval, the lower bound is going to be 1. It does not include 1 because it's an open circle, so we're going to give it a parentheses. And then it goes forever in the right direction, towards the right, okay? So we're going to infinity, we're going to give it a parentheses because we always give the parentheses to infinities. And then we're going to connect these 2 with a U for union, okay? So if you're writing this into the formative, the problem set, just type in a U, the letter U, because it doesn't have a union symbol on the keyboard, so that's fine. All right, oh, I keep forgetting this eraser is so big. So let's take a look at some examples here. Okay, to solve OR inequalities, solve each part, then graph on a number line to show the solutions. Okay, so like we talked about in class, we're going to solve each of these individually as if they were their own separate inequalities, and then we'll just combine the solution set together here. Okay, so we have 3x plus 4 is less than or equal to 10. We'll subtract 4 from both sides, and we get 3x is less than or equal to 6. Divide by 3, x is less than or equal to 2. Okay, and then this one over here, we'll divide by 5. X is greater than 9. Okay, so we have 2 sets here. Let's start with the one on the left. We'll graph our circle on 2. So you can either graph on or above. Let's do on here. So x is less than 2, so close circle on 2. And it's less than, so we're going to go here in the left direction and always keep an arrow with our graph. Okay, and then x is greater than 9, so open circle on 9 going to the right. Okay, interval notation now. So let's start with the left side here. It's x is less than or equal to 2, so we're going to go in the negative infinity direction with parentheses, all the way up to 2. Bracket because it includes it, and then union, our lower bound is going to be 9, not including 9, so we're going to do a parentheses, 9, comma, infinity, and close it there. Okay, so we can do one more. Let's do one more really quickly, and then move on to the and inequalities. Okay, so we have n plus 6 is less than or equal to 5. Let's subtract 6 on both sides. N is less than or equal to negative 1. Okay, and then we have 9n plus 7 is equal to greater than 43. Subtract 7 from both sides. We get 9n is greater than 336. Divide by 9. N is greater than 4. Okay, so we have this n is greater than 4, or n is less than or equal to 1 here. So let's graph these, starting with the smaller one. N is less than or equal to negative 1. So a negative 1, close circle. We're going to the left here, with an arrow. N is greater than 4, open circle, going to the right. Interval notation, let's start with the smaller interval. So we're going to negative infinity. It gets a parentheses all the way up to, oops, I graphed that on negative 3. This is actually negative 1. There we go. All the way up to negative 1. It includes negative 1, so we'll give it a bracket. Union, it doesn't include 4, so open parentheses, 4 to infinity, parentheses. So there are your OR inequalities. Let's scroll down to the AND type. So the AND, these are going to be overlapping, okay? It tells you two things about, it gives you two conditions, and it has to satisfy both conditions, okay? So here we can see, this is our graph right here. It covers all the numbers between negative 2 and 5, not including 5. Okay, so the way that we write this is with two different inequalities. We say x is greater than or equal to negative 2, right? Because we have the circle on negative 2 and it's closed, so it includes it. But it doesn't go more than 5, so x has to be less, so we'll say and x has to be less than 5. Not equal to, because we have an open circle. Okay, so the way that we write this in interval notation is we look at our lower bound, which is negative 2. It includes it, so we give it a bracket, negative 2. And our upper bound is 5, not including 5, so we just close it like that. Okay, so because the solutions to an AND inequality fall between two endpoints, they're frequently written in a more condensed form. So this is, we kind of practice this with our ADA compliant activity where we just kind of squish these together. So if we have this inequality where we say x is greater than or equal to negative 2 and x is less than 5, since it's between these two numbers, we'll write the smaller number first, negative 2. So x is greater than or equal to that number, but x is also less than 5. Okay, so we write it as this one, this like combined inequality there. Okay, so let's look at two examples here. Let's do number 7. So we can solve this as, since it gives us as two individual ones, we'll solve it as two individual inequalities and then combine the answer afterward. Okay, so let's look at 2x plus 3 is greater than 9, so we'll subtract 3 from both sides. We get 2x is greater than negative 12. Divide by 2. X is greater than negative 6. Okay, this other one, we'll add 2 to both sides. 8x is less than 32. We'll divide by 8. X is less than 4. So we're saying x is greater than negative 6 and x is less than 4. So if we write these as a compound inequality together, we'll write the lower end, negative 6. X is greater than that, so we'll write it this way, and then x is less than 4. So graphing this, we have an open circle at 6, an open circle at 4. and we're connecting everything in between. And in interval notation, we're going to write our lower bound, -6, our upper bound 4. It does not include either one of these values, so we'll just write them in parentheses like that. All right, let's look at number 9. Okay, so this one is a little bit different only because we have 3 sections of the inequality here, okay? The only thing that changes is that when we do something to one side or one part of this, we have to do it to all 3. So for example, actually let's move over to this one because there's a couple different things here. So for example, we want this to be written as something less than p less than something, right? We want to get p in the middle all by itself. So this is what we're going to focus on undoing until we get p by itself. So to get p by itself, we first have to subtract 4. We subtract 4 in the middle, we subtract 4 on the left, and we subtract 4 on the right. Then we get 0 is less than 3p is less than 15. And then to get p by itself, we have to divide by 3. So we'll divide each section by 3. 0 divided by 3 is 0, which is less than p, which is less than 5. And here, our inequality is already written as a compound inequality for us. So let's go ahead and graph that really quickly. So it does not include 0 or 5, so at 0 and 5 we have open circles, connect in the middle. Write our interval notation, our lower bound is 0, upper bound is 5. It doesn't include either one, so we're going to use parentheses. And that is your and inequality.